Hello, 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 and welcome everybody to another fabulous math class. I am Mr. Taco. How are you? It's nice to virtually see you. Today, we are working on multiplying to find equivalent fractions. Here are our supplies for the day. Here's our talking points, teaching points down below. I can identify a fractional equivalent of 1, and I can accurately multiply a fraction by an equivalent of 1. Should be a fun day. Let's get started. Before we start, I want to just briefly review about what a fraction is. Our numerator and our denominator. Those are the two parts to a fraction. Particularly today, we're going to think about the denominator, because in order to add and subtract fractions, you need to make sure your denominators are the same, so your piece is the same size. Okay? If you're trying to add 2 large pizzas and 3 small pizzas, you know you have 5 pizzas, but what size are you trying to add together? Okay? When we add and subtract, we need our quantities to be of a uniform size so we can accurately add them and have some sort of answer that makes sense. So our denominator is going to be really important here. And our numerator is the number of pieces of that size that we're dealing with. Okay? And just a reminder on equivalent, the word equivalent means equal in value or amount. So when we're talking about, and when we say equivalent fractions, we're meaning fractions that are of the same size. All right? Our rule today. If the numerator and the denominator are the same number, that fraction is an equivalent of 1. It has the same value as 1. And we can draw that out. If I'm dealing with 1 whole here on our fractions bar, our 1 fractions bar, no matter how many equal pieces I divide this fraction up into, the value, the blue amount, is not going to change. So we're always dealing with the same value here. So if I divide it into halves, there's 2 halves filled in. So we have 2 halves, which still equals 1. We divide those halves into halves. So we end up with 1, 2, 3, 4 pieces. 4 fourths, right? Still equivalent of 1. We haven't changed the value of our blue area here. We haven't changed the value of the amount that we're talking about. Okay? Same thing if we could divide each of these into thirds. So now we have 3, 6, 9, 12 twelfths. All of these fractions have the same value. They all equal 1. Why is that important today, you might ask? Well, here's why. We know from being fabulous multipliers that anything, any amount times 1 is going to equal that same amount. Like 5 times 1 equals 5 here, or 10 times 1 equals 10, 100 times 1 equals 100, 2,500,000 times 1 is 2,500,000, or 68 quintillion times 1 is 68 quintillion, right? That would be a very, very long area model if we were going to draw that out, so we're not going to, obviously. But this idea that anything times 1 equals the same amount. We don't change the value here. Okay? This is important when we talk about our equivalence of 1, because since anything times 1, we don't change the value. Anything times an equivalent of 1, we don't change the value. For instance, if instead of 1 here, we took our 2 halves. Okay? Instead of 1, we took our 2 halves, and this sentence, this math sentence is still true. This equation is still true. 5 times 2 halves is still going to equal 5, because 2 halves is the same thing as 1, and that goes for any equivalent of 1. 4 fourths, 12 twelfths, a millionths. We can get as absurd as we want, but as long as the numerator and the denominator are the same number, this equals 1. And so we can multiply by it or divide by it, and we're not changing the value of our starting point. Okay? How does that apply to fractions? If we take a look, instead of 5, what if we had 1/5? What if we had 1/5? This is an extension of what we talked about yesterday. Good question. So rather than just going into the visual model, we're going to really be talking about the multiplication piece today. Okay? So what if we had 1/5 times 2/2? Let's draw that out in a fraction bar so we can see what we're talking about. 1/5 okay? And when we say we're multiplying by 2/2, what we're doing is we're taking each of these fifths, cutting each of those fifths into halves, and we're still dealing with the whole value because, again, we're not changing the value. If we were multiplying it by 1/2 or 3/2, it would look really different. But all we're doing when we're multiplying by an equivalent of 1 is we are cutting each of our pieces, each of our fifths, into 2 equal pieces. So then we end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces total. So there's our denominator. And then how many pieces are shaded in? 2. Do you notice anything about our numbers here? Take a look at the numerators. 1 times 2 equals 2. Now take a look at the denominators. 5 times 2 equals 10. So our rule with multiplying fractions is different than adding and subtracting. Our denominator will change here because, like we showed, we're changing the size of each equal piece. So here we're going to multiply the numerators, multiply the denominators. Does this work every time? Let's try a different one. This time we're going to first do the multiplication and then we're going to check it with our visual. Okay? So let's go with something like 2/3 times, and let's think of an equivalent of 1 here. Can be anything. Maybe, let's go 4/4. That's an equivalent of 1 because the numerator and the denominator are the same number. Okay, so now what we're going to do, we're going to multiply on top. 2 times 4 equals 8. I knew you knew that. And then 3 times 4, don't sleep on your fingers. Your fingers, even in 5th grade, your fingers are still a valuable mathematical tool. We could go 3 groups of 4, 4, 8, 12. Or we could go 4 groups of 3, 3, 6, 9, 12. Same answer both times. So we have 12, 8/12. Now let's draw that in a visual and see if it matches. Here's our fractions bar. We're going to start with 2/3. Divide this into thirds, and we're going to shade in 2 of our thirds, because those are the 2 we want to focus on here for this fraction. Now we're going to multiply it by 4/4. What that means is we're going to divide each one of these thirds into 4 equal pieces. Okay, so now let's check it. Make sure our denominator is correct. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. And are there 8 pieces shaded in? Do we have 8 in our numerator? 1, 2, 3, 4, 5, 6, 7, 8. You bet we do. So this shortcut does work. Choose your equivalent of 1, any fraction that has the same numerator and denominator, multiply the numerators to each other, then multiply the denominators to each other, and you will end up with an equivalent fraction to what you started with. Pretty neat, huh? Let's go to our digital whiteboard here, leave our in real life whiteboard behind, and let's try some practice problems. So here's our first one. You'll notice there's some question marks here where we're missing some information and we need to figure it out. So 3/5 times something equals 6/10. So again, we need to think about our rule of multiply the numerators to get a product and then multiply the denominators to get a product. Okay? So 3 times something is going to equal 6. 3 times what? 3, 6, 2. So let's try putting a 2 here. And if we're dealing with an equivalent of 1, stands to reason that this is going to be 2 halves because our numerator and our denominator have to be the same number. And does 5 times 2 equal 10? Why, yes, it does. So we know here we've got the right fraction to fill in the blank. And we can prove it. Let's prove it quickly. Let's make fifths. Color in 3. And then we're going to divide each of our fifths into 2 pieces. And then we end up with 1, 2, 3, 4, 5, 6, 7, 8. Oh, I'm not touching the screen hard enough apparently. 7, 8, 9, 10 with 1, 2, 3, 4, 5, 6 shaded in. So we do have our 6/10. Nice. Okay. Let's try one more. Or actually, we'll try 2 more. Let's start with this one. 2/7 times 3/3 equals what? I'll give you a little bit of time to try this one on your own. Okay. We have both of our parts to our multiplication equation, and now we need our product. So remember, multiply the numerators straight across, and then multiply the denominators straight across. While you're working, I'm going to draw some blue fluffy clouds on top here, just to give a little ambiance as we work. Great. Here we go. 2 times 3 in our numerators, that is 6. And then 7 times 3 for our denominators, that is 21. 3 groups of 7 or 7 groups of 3. That 1 is wonky, so I'm going to rewrite it a little bit nicer. There we go. 6/21 is how we would say that. 2/7 with each of those 7ths broken up into thirds. We end up with 6/21. So we have 6 pieces, and the size of each piece is 1/21 of our whole. Okay? Last one. This one's a little trickier. 4/5 times something equals 16 something. We got a bunch of missing pieces here. So let's think logically about what we can do. We know that numerator times numerator is going to get our numerator in the product. We know denominator times denominator is going to get us our denominator in the product. But do we have enough information yet to know what our denominators are? Not really, huh? Because we only have one of the three. But we do have enough information on top. We know that 4 times something is going to equal 16. Think about it. Use your fingers if you need to. 4, 8, 12, 16. How many fingers am I holding up? I'm holding up 4 fingers. So we have 4 times 4 equals 16. So we know it's 4/5 times 4 somethings equals 16 somethings. How do we figure out that denominator? Well, if we're finding equivalent fractions, what needs to go under that 4 to make it an equivalent of 1? Remember, our numerator and denominator are the same number. That fraction is an equivalent of 1. So this question mark below our 4 here has to be, if we're making an equivalent fraction, it has to also be a 4. Okay? Otherwise, we're not multiplying by an equivalent of 1, so we're changing the value of our starting number. Okay? So now we know what we need to do on the denominators. 5 times 4 equals what? 5, 10, 15, 20. And we end up with a final product of 16/20. Okay, where we have 16 pieces, and each piece is 1/20 of a whole. All right. Thank you, everybody, for tuning in. I really appreciate it. The chat looks great today. Nice job with the chat, everybody. I would love to use this as continue to use this as a question and answer space. So wonderful. I'm glad we're staying on topic in the chat today. Nice work. So small group plus our drop-ins. Remember that starts at 11 o'clock. That's in about 10 minutes from as I'm saying this. And the exit ticket will be on Google Classroom shortly. Try that out. If you have questions or feedback, remember, drop into the Zoom room starting at 11. Take care, everybody. Have a great rest of the day. Remember, what's the rest of our schedule? PE on Zoom at 12:30. Yeah. Then take a little brain break after. And then we have science back here on our YouTube channel at 1:15. All right? Don't forget to like and subscribe. I've always wanted to say that on YouTube, and I haven't done it since I started this. Incredible. Don't forget to like and subscribe. Hit that notification button, even, so you know when live lessons are coming up, so you don't miss a thing, and you flourish in this distance learning 5th grade world. All right, everybody. Take care. We will see you on Zoom for our small group. Have fun.